Okay, so factoring quadratic trinomials was the focus of our studies last week. You also spent some time practicing those skills at the beginning of this week. Today, we will focus on solving equations that require factoring and then finding roots or zeros of polynomial equations. We'll look at 4 examples in this video. The first two review concepts that you have studied. The next 2 examples will serve to kind of bring all of these ideas together. So let's take a look at this first problem, the opener. Now, what a lot of you might do is if you look at this problem, you might think that dividing by 2x is the way to go here, okay? And actually, that's not the way that you want to start off this problem. Okay, what we want to do here is we want to get all of the terms that contain x and any other constant values on one side of the equation. So basically, we want the polynomial expression on one side of the equation, and the other side of the equation we want to be equal 0. And I'm going to discuss why that is in just a second. So I'm going to subtract 4x from both sides. And that's going to leave us with 2x squared minus 4x equals 0. And this is actually the equation that we want to solve. Now, the reason why is if we think back to the very first video, and this is maybe a week or two ago now, we talked about the graphs of polynomial equations being parabolas. And the graphs of quadratic equations, parabolas, can potentially intersect the x-axis twice. So if we were to divide both sides of this equation at the beginning by x or by 2x, what's going to end up happening is we're going to lose one of those potential roots. So the process that you want to go through is getting all the terms for your polynomial on one side, set the equation equal to 0, and then you're going to solve. So how do we solve this? The first thing I would do here is there appears to be a greatest common factor that we can factor out. So I'm going to factor that out up here. We're going to get 2x is our GCF, and then we'll divide each of those terms by 2x. So 2x squared divided by 2x is just x. Negative 4x divided by 2x is negative 2. So now we're in a great position to use the zero product property to help us find the solution. So we get 2x equals 0 or x minus 2 equals 0. And then we can solve both of these equations to find the solutions to the original equation. So x equals 0 is our first solution if we divide both sides by 2. X equals 2 is our second solution. And again, if we go back to the original equation, 2 times 0 squared equals 4 times 0, which is correct because 2 times 0 is 0 and 4 times 0 is also equal to 0. And then we have that second solution, 2 times 2 squared equals 4 times 2. 2 squared is 4, so 2 times 4 is 8. And then 4 times 2 is also 8, which is a true equation. So again, the key to this is we want to make sure that we're setting the polynomial expression equal to 0 and solving so we get all the potential roots or solutions for that equation. Now let's take a look at the second example. 2x minus 3 times the quantity 4x plus 5 equals 0. Now at this point in time, you should be able to solve an equation like this pretty easily. Again, we're going to apply the zero product property here, so we're going to set each factor equal to 0. And then we'll solve those equations. So we'll add 3 to both sides. Get 2x equals 3. And then we'll divide both sides by 2, and we'll get x equals 3 halves. Or subtract 5 from both sides. We get 4x equals negative 5. And then we'll divide both sides by 4. So x would equal negative 5 fourths. So the solutions to this equation should be x equals 3 halves or x equals negative 5 fourths. So you're probably wondering, why did I go through all of this review in this video? And the reason why is because we're going to start to solve problems like numbers 3 and 4. All right, and this kind of goes back to a discussion that we had a while ago. There are quadratic equations, and there's other polynomial equations as well, but we're going to focus mainly on quadratic equations that are written in standard form. And we need to take that quadratic expression that's written in standard form and factor it into the product of linear binomial terms so we can solve the equation using the zero product property. So let me explain what I mean by that. Let's take example number 3, and it's kind of hard to see, but this is the function, or the equation rather, that we're going to be working with. All right, so this equation is kind of like a combination, or the way that we're going to attack this equation is kind of like a combination of the techniques that we use in examples 1 and 2. So let me show you what I mean by that. So if you look, all the terms of this polynomial expression are not currently on one side of the equation. So what we're going to do is we're going to manipulate the equation to make sure that's the setup to get started. So the way that we're going to do that is we're going to subtract 3 from both sides. And now we've taken and set the polynomial expression equal to 0. Now, here is where we're going to apply the techniques that we learned last week, the factoring techniques that we learned last week, to help us get this expression, which is, and I'll highlight it for you, 8x squared plus 10x minus 3. Convert that from standard form into factored form, and then we can apply the zero product property just like we did in problem number 2. So let's go ahead and get 8x squared plus 10x minus 3 into factored form. All right, so we're going to use the Xbox method to do this. So let's multiply the constant term and the quadratic term together. That's going to give us negative 24x squared. And we're looking for factors of negative 24x squared that add up to 10x. I'm going to do that calculation over on the side, so negative 24x squared. So I'm thinking about factors of negative 24x squared that would add up to 10. So that should be a positive 12x and a negative 2x. 12x times negative 2x is negative 24x squared. 12x plus negative 2x is positive 10x, so that worked out nicely. All right, so now we can go ahead and factor using our area diagram. Hopefully that's big enough. We'll see in a minute. All right, so we're factoring this original expression up here. So I'm going to put the quadratic term of the original expression in the top right-hand corner, constant term bottom left, and then these two linear terms in the remaining two empty boxes. And then remember, we're factoring the GCFs, so the greatest common factors of the rows and the columns. So let's do the rows first. GCF of 8x squared and 12x should be 4x. GCF of negative 2x and negative 3 is a negative 1. GCF of 8x squared and negative 2x is 2x. There we go. And then the GCF of 12x and negative 3 is positive 3. So now we're going to take each of those factors and set that equal to 0. So what we've done is we've replaced, in this equation right here, oh, it's actually down here, sorry, 8x squared plus 10x minus 3, we've replaced that with its factored form. And now we can apply the zero product property to find the solutions. So this first one, it looks like x is going to equal subtract 3 divided by 2, so negative 3 halves. Add 1 divided by 4, we get x equals 1/4. So it looks like these are our two possible solutions to that equation. So what you're seeing here is it's not all that different from what we've been doing up to this point. Now we're just taking that additional step of taking each of the factors, applying the zero product property, setting them equal to 0, and solving to find the solutions to the equation. Now, number 4 The directions are a little bit different, and the format in which the equation is given is a little bit different. And I want to highlight that for you right here. So if we look, here's your equation, and it's written in function form. So it says find the zeros or the roots of the polynomial. So essentially what this is asking you to do is to find the x-intercepts of this function. We want to find out where the graph crosses the x-axis. The way that we do that is we set our function value, which is really the y-coordinate, or the set of all y-coordinates of every point that's on the graph. We're going to set that equal to 0 because all x-intercepts have a y-coordinate of 0. So let's take 16x squared plus 14x plus 3 and set that equal to 0. Now this equation looks a lot like the equation that we saw in example number 3. So what we're going to do is we're going to take and we're going to write 16x squared plus 14x plus 3, which is a standard form quadratic, and we're going to write that in factored form. So I'm going to do that below. Grab a different colored pen real quick. All right, so we use the x box method. I'm multiplying 3 times 16x squared. That's going to give us 48x squared. And now we're looking for factors of 48x squared that add up to 14x. So 48x squared, I'll do that off to the side like I normally do. That should be, I think, a positive 6x and a positive 8x. So 6x times 8x gives us 48x squared. 6x plus 8x gives us 14x. So we are in business. All right, so now we're going to factor using the area model. So top left-hand corner, 16x squared. Bottom right, positive 3, the constant term. And now we're going to put our two linear terms that we found just a minute ago. So these two terms in the remaining two empty boxes. GCFs of the rows and the columns. So GCF of 16x squared and 8x is 8x. GCF of 6 and 3, positive 3. GCF of 16x squared and 6x is 2x. And then the GCF of 8 and 3 is positive 1. So we're going to take and rewrite the original expression now in factored form. Set equal to 0 so we can find the x-intercepts of that function. So 2x plus 1 equals 0, or 8x plus 3 equals 0. So I'm going to subtract 1 from both sides in that first equation, divide both sides by 2. We're going to get x equals negative 1/2. Or subtract 3, divide both sides by 8. We're going to get x equals negative 3/8. So in a situation like this, when we're asked to find the roots, I'd like you to give me an ordered pair because the roots represent where the graph is crossing the x-axis, and points in the coordinate plane have two coordinates, an x and a y coordinate. So the first solution is 1/2, 0, or negative 3/8, 0. Now what I'm going to do is quickly take you over to Desmos after I highlight these solutions. And what we're going to do is we're going to see if the graph actually crosses the x-axis at negative 1/2, 0, and also negative 3/8, 0. So let's take a look. Get out of this. Go over to Desmos. So I've graphed the function ahead of time in advance. Now it's kind of difficult to see exactly where the graph's crossing the x-axis here. The good sign is the x-intercepts that we found were both negative, and that appears to be happening in this graph here. So let's zoom in and see if we can locate the exact coordinates of the x-intercept. So I'm going to click on the first one, and negative 0.5 is equivalent to negative 1/2. and then click on the next one. Negative 0.375 is equal to negative 3/8. So it looks like we have found the correct x-intercepts. Okay, so I hope this video was helpful. You're going to do some practice problems now. As I've said in each of the videos, if you have any questions or concerns, feel free to email me or message me through Google Classroom. I hope this was helpful, and we will see you in the next video.